conversion of carboxylic acid into acid chlorides. Now, you probably know by now that you can't simply just add a Cl minus, a chloride ion, to a flask or a round bottom flask with carboxylic acid in it, like acetic acid, and expect the reaction to go to completion to make the acid chloride. You should know, based on the chart, let's go back up here, that this is the most reactive, and you can go this way, but you can't go back the other way. So let's draw this out so you can see it. So if we have, let's say, an acid chloride here to be made from carboxylic acid, and we react this with Cl minus, expecting things to go smoothly. I mean, Cl minus can come from as simple as table salt, really, like from sodium chloride. There's a reason why no reaction happens when you add salt to carboxylic acid or even alcohol, because Cl minus is a weak base. So you have I've added this. Now, we know the intermediate. When we make the intermediate, tetrahedral intermediate, the molecule is going to evaluate whether we should kick out the OH or the Cl. We know the Cl is the better leaving group, the best leaving group. So guess what? You are back at carboxylic acid, or back to it. So whenever this is given to you, you just say no reaction. However, the carboxylic group can be actually converted. We saw that maybe in chapter 9, very briefly, with alcohols. It can be converted into an acid chloride by using two reactions, especially one for the Cl, one for the Br group, for the bromine. And here they are. So if we react the carboxylic acid with SoCl2, we can easily replace it. Replace the OH with Cl. And the reaction will, how does that happen? Well, we have to look at the mechanism. So in the mechanism here, is you are attacking the S. Okay, this involves actually multiple steps here, but let's actually put the arrows, put the electrons on the OH, and then draw SO Cl2. And when that happens in here, just quickly, let's just show that. This is kicked out. And you have this. Now, what did we do here? What is so special? So special is that this is now an oxygen with 3 bonds. So this is now a good leaving group. So therefore, the Cl minus that was kicked out, this Cl minus can act as a nucleophile. So finally here, so now when the electrons come down, this is kicked out. And of course, you're forming the acid chloride. So yes, an acid chloride can be made if you use a special reagent of SOCl2. Same thing with PBr3. So or even PCl3 or Cl. So this would easily give you the acid bromide.